Hi everyone. Before I start today's lecture, I want to remind you that we are going to have the course project presentations online. Well, as you may know, we can't have face-to-face contact, and what we have to do is, I'm asking you guys to make presentation videos and submit that to YouTube, as what I have been doing in the second half of this semester, and this the hyperlink to your YouTube video should be shared to the Slack channel. Okay, so in this way, and you record the video, and then everyone else in this class will be able to see what kind of cool project you have already done. Okay, so for the submission, you need to submit a IPYNB file, which is the code base, and you don't really have to add a lot of the description or explaining what you have been doing in your project because you are going to do a separate report. So IPYNB is a cool thing that you can combine your documentations, the descriptions, and with your code. But the problem is if you add too much content together, and then the Jupyter notebook may get really long and it can be hard to read. Okay, so in your code base, you don't have to add a lot of the explanations, and if you want to explain what you have done or what is the background of your project and why you pick the machine learning algorithms and how you better improve the performance of the machine learning models. And in addition, how do you explain the results and how do you evaluate your results? Is your result good or not so good? And if your result is good, why it is good? And if your result is not so good, and why it is not so good? Is there something wrong with the data, or the problem itself is hard and you can't get a really good result? So for those kind of content, keep that in your report. Okay, you separate the code and then your report, and don't remember you have to record a video. And if you want some suggestion on what kind of software I have been using, and I have a couple of recommendations for you guys. Okay, and then when you make the presentation as a video, and I'm requiring you guys to use PPT or some visual aids. You can decide what kind of the visual aids you want to have. And for every team member, you need to present at least part of it. So I have been emphasizing the soft skills. So you need to be comfortable in talking to people in different scenarios. And usually in my courses, I require students to do the presentations in front of all the students and probably some professors as well. But in this case, you have to present to your camera. Okay, so that is actually different. Well, when you present in front of a group of people, and you may feel nervous, and when you are presenting to your camera, the problem it's might be easier, but the problem is different. The problem in with presenting to your camera is sometimes it can be a little bit hard to be excited about the things you are presenting. Okay, so go ahead and try to make your own videos and see how it works. Okay, and for your presentation, it should be 15 to 20 minutes long. And for the Q&A, it will be done on Slack. So when you see other people have already posted their videos, go ahead and click on that link and see the video. And if you see some of the problems, or you want to comment, and go ahead and do that on the Slack channel so we can have discussions or conversations. And if I see some of the problem with your project, I will also add my own comments to your videos. Okay, so the deadline of the submitting everything, submitting the code, the report, and then the video will be on the April 30th. Okay, so that's for the course project part. And today we are going to move on to a new clustering algorithm called hierarchical clustering. And you may see another word, and that is the name used in the scikit-learn, and that is agglomerative clustering. And Well, agglomerative clustering explains exactly how it works. Well, but for the hierarchical clustering, it is just a more commonly used word. So in my lecture, I'm going to use the hierarchical clustering. But if you see agglomerative clustering, that's the same thing. Okay, so for the hierarchical clustering, and the long story short, we are trying to merge the samples into small clusters, and then we are going to merge the smaller clusters into bigger clusters. So we just merge the smaller clusters like we merge small drops of water. And when do we stop? So we are going to stop when we only have a specified number of the big clusters remaining. Okay, so well, in this case, we do have to define the distance, because when we are combining two samples into a cluster, or we are combining two smaller clusters into a bigger cluster, and then we do have to define the distance. And when I say the word distance, you should know we have to apply the scalar, right? So whenever we are trying to make use of some distance matrix, you need to do the scaling. And there are two types of the distances we have to measure. So the number one, of course, when we have two samples, we have to measure the distance of two samples. And in addition, there is another type of the distance measure, that's the distance measure between two clusters. So well, I have the lower d and the lowercase d and the uppercase d for those two different type of the distances. So I'm gonna draw a small example and show you what is it. Okay, so in this case we only have 6 samples, right? So if to start, we are considering all the samples to be one single sample cluster. Okay, so we have a total of 6 clusters, and then we want to merge the two clusters which are closest to each other. And what are they? And you can say, okay, those two, right? Okay, so those two samples will be merged into one cluster. So now we have a total of 5 clusters. And the next part, we want to do another merging. So which two should we merge? And then it should be those two. Okay, and then if you want to merge again, and we are going to merge those two. Okay, so after that, we have 3 small clusters, and each of them has 2 samples. And after that, how do we measure the distances between the clusters? Now we have the problem. So well, let me give you one idea. Well, this might be the idea comes from the k-means. So how about we just get the centroids of the clusters, okay? And then we can say, okay, the distance of the centroids, and by comparing the distances between the centroids, and then what we can say is, okay, those two should be merged. Well, is that the only way? The answer is no, but this might be an intuitive way. Okay, so let's come back to our lecture. So in for the uppercase D, well, there are several ways that we can measure the distances between the clusters. So the most the most common one, or probably the most straightforward one, is the single link. So single link is the smallest distance between any pair of the two samples of those two clusters, and then we just find the minimum, and then that will be considered as the distance between those two clusters. And on the opposite, we can also do the complete link, and that is the maximum between the two samples in those two clusters. Okay, and if you say, well, if we only take the minimum or the maximum, and it might be what do I say? Well, it might be a overfit, and then what we can do is, how about we just consider all the possible linkages, and then we have the average. And as you can see, for the average, and then we do have to compute, and then do the average of many distances. So the average can be a little bit more expensive. And well, in the scikit-learn, the default way is to do the word linkage or the word distance between two clusters, and that is to the minimum of the variance of the two clusters being merged. Okay, so and the word is the default way to measure the distances between clusters. Okay, and well, when I created this section notes 2 years ago, I guess, and then at that time, well, somehow in that version of the scikit-learn, the single linkage was removed from the scikit-learn. And I checked that again just now, and then the single linkage has been added back. So, well, this is the thing you want to pay attention to scikit-learn. Well, scikit-learn is a evolving package. So you have that work 1 year ago, and it doesn't guarantee that you can have that work again. So this is a painful part of for you to do machine learning sometimes, because well, the packages, the technologies, they are always evolving. Okay, and well, I think I should stop here because it's already more than 10 minutes. And I'm gonna stop my video here, and I'm gonna continue in the next video.